Okay, so I promised you guys a video that showed you how to actually complete the statistics for your lab report. So these are all of the materials available for you on Canvas. The top one here is just where I input the grade. You don't need to worry about this. This is a important document, a lot of details in here about the experiment. Gives you for each of the sections some good pointers on what I'm looking for in those sections. This is the PowerPoint that I presented in class, and here is a video of that lecture. So these two are very similar in terms of, you know, the contents. The PowerPoint one does sort of demonstrate how to use APA. There are some example citations at the end. Here are all the movies themselves that you'll use to count the number of crossings. Here is the data, which I'm about to use to show you how to do these statistics. So let's see, I need to go here, and then it will download the data. So you'll have to certainly open this and use this in Excel. Okay. There we go. Okay, and when you open it, you're going to see all of our logs, log 1 through 10. These are not in order for some reason. Here's the characteristics of the log that you helped me to measure. Right, all of those were used here. To calculate the crossing score. So at this point, this data is here, but you don't need it. And we've summarized all that into this crossing score. So the assumption is the higher the crossing score, the better the log for crossing. This shows you the latitude and longitude of where the log is. And then there's this other stuff. Okay, so your job, and you'll see that I have gone through and filled out 5 of the 10. I went through and counted for each of these log 1, log 6, log 9, and log 10. I counted how many videos of animals crossing the log there were. Okay, and that number is there. The way I did that is relatively simple. Let's just look for log 5. Right, for log 5, let's see, for log 5, lab experiment, log 5. You just open up. This is what the folder looks like, and you're going to open it up, and I would just keep yourself a tally. Keep yourself a little sheet of paper beside you. Open up all these videos for log 5 and look at each of the videos and tally whether or not you see an animal crossing. Okay, because there's going to be some videos like this. I'm not seeing anything in this video. Right? You probably want to open up a bunch of them. Obviously, this is a pain to do it like this, but if you download those videos and then look at them on your computer, you should be able to just toggle between from one to one to one, from this one to the next, and so on and so forth. It's not allowing me to do that on here, but eventually. So far, I would say, oh, what the hell? Every time. Eventually, you're going to find a video with an Animal Crossing in it, right? And you will then tally 1, right? Whatever that number, that final number, the number of animals you see crossing that log goes in here, okay? And you'll see, right? I've counted through log 6, there were 11 animals. Now, these other 2 columns, this is the number of nights or 24-hour periods within which that camera was running on the log. Most of them are up here, 64, 63, but like for example, number 9 there are fewer trap days. That's because this whole camera got washed away in the last storm last week on Friday. Now I had gone and downloaded the pictures previously, and so we got at least 46 days of trapping. And during that time, we only saw 2 animals, right? Here, this one's very low because this is log 8, where the cows were. You go to the bottom of the hill and make a right. It was that first one there that I think Sarah and maybe Princess put up. And this one only had 21 trap days because the cows really liked the camera and knocked it over multiple times. Okay, but within those 21 days, we got 15 pictures. So basically, if you think about it, that you can't really compare this 15 to this 42 because this camera was only running for basically a third of the time that the camera here was. So what we need to do is standardize the number of crossings per number of days effort. Okay, so if you have a camera running twice as long, all things being equal, you would just assume that you'd get twice as many pictures. Okay, so what we're going to do is this last column here is basically the number of crossings divided by the number of days. So that will be a standardized measure of how many animals per day were observed crossing that log. Okay, so all you really need to do is fill in these numbers. Right, go through the folders for 5, 4, 7, 2, and 3, and put in the number of Animal Crossings. And this is just fictitious data that I'm going to put in here. Okay. So say you found these numbers, and you'll see the formula is all set up for you. Once you fill these in, you're going to get your standardized measure of number of crossings per day. Okay. Now, this is all the data that you need to do your statistics. Okay. This is all the data you need to do your statistics. And really what we're, again, if we go back to our hypothesis, I would hypothesize that we can predict the number of crossings per day based on characteristics of the log. I.e., if I know the crossing score, I can predict how many crossings there will be per day. That would be my hypothesis. So my prediction would be then these two variables should be positively correlated. And so we're going to test that hypothesis by calculating the Pearson coefficient between these two variables. And the way you do this is you do equals. Go to any, it doesn't matter which cell you pick. Just pick a cell, start by typing equals. All right, you see that here. Equals Pearson, and then parentheses. Equals Pearson, parentheses. Now it's looking for two of the variables. Again, we want to see, is there a correlation between this variable, comma, and this variable? That is what we're asking. Is there a significant correlative relationship between these two? Not this variable, again, because that's not been adjusted for effort. Between this one and this one. And then hit enter. This number right here is your R. This is R equals 0.1247, etc., etc. Now, what we don't know is what is our p-value, okay? Because at the end of the day, this is what we need to know. We need to know, is this p-value greater than or less than 0.05? We need to know our probability of crying wolf, and we want that probability to be very low. If we say there's a relationship between crossing score and crossings per day, we want to be confident that that's the case. So if we go back to Canvas, right, we go to our modules and we look in lab report, you'll see I put a link to this p-value calculator. Okay, click on that. Well, I'm not gonna. It goes to this website. Okay. All you need to do is 3 things. Get your R, 0. Well, and I think you can probably just No, 0.1247. 0.1247. The n, this is the number of samples. This is the number of logs, which was 10 in our case. We're looking for a significance at p equals 0.05. This is our p-value. Your p-value is 0.73, which this website even goes a step further and tells you that it is not significant, i.e. it would need to be less than 0.05 in order for it to be significant. It's much greater than 0.05, so our p-value here is 0.73. So what that tells us is if I say there is a relationship between crossing score and the number of crossings per day, I will be crying wolf 73% of the time, which is totally unacceptable, right? That is to say, what this tells us is there's very likely not a relationship between crossing score and crossings per day. Okay, but this is just, remember, I just filled in this fictitious data here, right? You fill in those 5, right? You fill in this one, those 3. Do the same thing again. Calculate your R equals Pearson array 1, array 2, end parentheses, hit enter, get your R. Once you get your R value, you're going to go to this calculator, put in your R value, put in 10 at 0.05, calculate what is your p-value, okay? Once you get your p-value, then, right, you have your results, basically. You have your results, at least one major part of your results, okay? Because if you look in here and you look at this description of writing a lab report, that's going to be a major part of your results section, is what is your p-value. And again, the p-value is not significant, therefore with these fictitious data there is no relationship between crossing score and number of crossings per day. So in your results, you are also going to report your statistics here, and you will, here's some examples of how to do this. You will report your calculated R, you'll calculate your sample size 10, you'll calculate your p-value, you'll report your p-value, and then I give you an example of exactly how to do this. Okay, so once you go through and you count the number of crossings, you get your crossings per day, calculate your R, get your P, right? You're a long way on your way towards having your results written. The other thing that you want to bring to the table for the results section is a scatter plot between these two variables. So here's what there's 1,000 ways to do a scatter plot. I'm just going to copy these. I'm going to make a whole new sheet, and I'm going to calculate or paste the values, and I don't need these anymore. All I need is a scatter plot between the number of crossings per day and the crossing score. So I do insert scatter plot, and let's see, we should have the let's see here. Is this the way we want this to look? Well, first of all, we're missing our axis label, and I personally, I don't like this up here. I would write that down on the bottom. Let's see. What's our dependent variable here? Our dependent variable is the crossings per day. Okay, so we're assuming that that is dependent on the crossing score. So, yeah, I think this is right. So you can go ahead and put your access titles in here. So this one is crossing score. This title is number of crossings per day.
Hey.
And we see that.
Are you free right now?
Hold on one sec. I'm recording a lecture.
Oh, I'm so sorry.
Okay, so that will give you your titles to your different axes. And then I think the last thing that would be nice for me to see would be the line through this. Okay, because again, if there is no relationship, it will just have a big blob of points, or the points will be in a straight line. Whereas if we are expecting a positive relationship, then you would expect there to be an increase. And I can kind of see, if you take this point out and you took that point out, we're getting a pretty nice relationship here. So let's see what the actual line would look like. So if you right click on here, it says add trend line. Okay, this will pull up. We want a linear trend line, and you can display the R squared value on your chart. Okay, and so what that tells us is our R squared value is pretty low. And in fact, if you take a square root of that, let's see, 0.0156, 0.0156. If I do equals square root of this, that should give us our R value. Should be 0.12, which it is, right? So in other words, this value that it's displaying here is the R value times the R value. Okay, so these are your results from your lab report. Again, these are not your results, but this is what your results will look like eventually when you go in and fill in these five values for the number of animals crossing. Okay, fill that out, calculate your R, go calculate your P here, right? Make your scatter plot, label your axes, right? All that stuff goes in here. Scatter plot graph, and it would be helpful to add a line through the dots with the R value. And actually, this should be R squared value. So that's your result section. Your intro section, right? Answer these questions, talk about your hypothesis, look at some of the specific background and impetus type of issues here. Your methods, talk about what you did. There's a lot of information in here about Dr. Flint's farm, and whatever else you need, you can ask for it. And then in your discussion, again, you're going to go back to the literature. You're going to interpret your p-value, and what does that tell you about your hypothesis, so on and so forth. Okay. As for literature in this assignment, I will put up, I don't know if it's here, I'm going to put up a folder that has some papers in there that can easily be used for the literature aspect of this lab report. So, all right, well, I'm going to can this and put it up on Canvas. I hope, if I can figure out how to turn the stupid thing off.